Hey, what's up, guys? It's Dark Shadow Codes back with another video. So today I'm going to teach you how to make this awesome constellation effect, and we can play around with the values a bit. So, as you can see, the main theory is basically particles are flying around, and if they're in a close proximity of each other, they connect. And then you might find this on the background of Blookit, but it's a little bit different. Or you can visit my official Constellation Effect thing on constellationeffect.shadowcodesjs.repl.co. I'll put the link in the description below. So anyway, I'll show you how to make it now. So I'm gonna create a new folder. I'll call it Constellation Effect. Select that folder. Now let's get in. So I'm gonna add my 3 files. And finally script.js. So the first thing I'm going to do, I'm going to create the whole thing. Let's call it Constellation Effect. So, okay, that's all the HTML we need to do. Now let's do a quick, let's like make no margin, no padding, and box sizing is border box. Okay, now let's move on to the canvas. So background black. Oh yeah, I'm gonna put live preview on. Width 100%, height 100%. Yeah. So now if I reload, bruh. Yeah. Did I type it right? Yeah, I did. So what's the problem here? Okay. I guess there's no problem. So var, let's create the canvas element. I'm trying to stop using var and start using the more modern keyword let. So let's make our context thing. Get context 2D. I want to learn how to use get context WebGL sooner or later, but that's for a separate time. So now let's make it inner width, make it take up the full screen, inner height. Okay, for some reason this ain't displaying, so canvas. Is there a problem with the CSS or something? Doesn't look like it. What if I take away the can percent height 100%? Okay, I'm gonna put a border to see. Okay, for some reason the canvas isn't displaying at all. So let me try opening it in a browser to see if it works. Yeah, it's not there, so that's strange. Let's figure this out. Strange bug. Oh, I'm such an idiot. I'm such a big idiot. Okay, so the reason it wouldn't load was the simple reason I forgot to link the files. There we go. Now let's I'll link the JS file in a minute. But first let me put all that stuff back. Oh my god, I'm so stupid. Box sizing, border box. I don't think we really need the border box and padding stuff. It's just the margin. So now let's link the script file. Yep, there we go. Okay. Why is there margin? Okay, a problem. Okay, yeah, some border box stuff. I'll make the padding. Oh, whoa, it's padding. Maybe I need the border box. You know what? Forget it. Yeah, it's fine. Whatever. Alright, so just to test if it works, let's ctx dot fill style is white. ctx dot begin path. Just to test if it works. 2020. I don't know. 20 0 math dot pi times 2 ctx dot fill. Okay, it works. Got it. So of course you could use p5.js, but I'm a completely vanilla guy unless it's React or Vue or something, whatever. So first thing, create the particle class. Let's get straight into it. So first let's add a constructor. I will make a random x. We'll do the same thing for the y. Now we I don't know, make a size of 5. Put a dx to see its for its velocity on the x-axis. 4 minus 2. We'll do the same for the same thing for the dy, and yeah, that's all we need. So now this part's easy. We can just begin a path. ctx dot fill style. We'll call it gray for now, and then ctx dot arc. We want to arc it. This dot x, this dot y, this dot size, 0 and math.pi times 2 to create a perfect circle, and then we fill, and then we can close the path. It's not necessary, but I say just do it, because why not? Now let's create a method called update. So first up, we want to say this dot x is increased by added. Okay, what is increased by this dot dx, and this is increased by this dot dy. Next, this is the hard part. So first, let's call the function init to initialize, and so we'll create for, and now we have to create another variable. Let particles equal an empty array. For let I equals 0, if I is less than n, and then particles dot push a new particle. It'll come in handy later. So anyway, for update, so we want to check if it's near anything. So for 0 I is greater than particles dot length I plus plus. So we have to make sure that the particle we're selecting right now is not the current particle that this is, so it won't bug out. So we do this. It's as simple as that. Then we want to say if that's true, then if it's not itself the particle that's been selected, if it's not the current particle, then we let the equals the absolute value of this dot x minus particles I dot x, and we do math dot abs to make sure it's a positive number. Because distance is always measured in absolute value. Then this dot y, distance y is the absolute value of this dot y minus the particle selected dot y. And then let distance. So we use the Pythagoras theorem. So thanks to math dot square root, we can do this. So it's a squared plus b squared equals c squared plus, so a squared plus b squared, in this case it's distance x squared plus the distance y squared, the square root of that whole thing, and that's the distance. So if the distance is less than, let's say, 40, then we'll create a line. So begin path ctx dot this time stroke style. We'll go with red for a laser effect, and ctx dot line. So first we move to this dot x and this dot y, the coordinates of this particle, and then we make a line to the selected particle's x, and this selected article's point, and we have a constellation effect. So that's that done, I think. So now let's create the animating function. So we'll make the fill style over here. Oh yeah, and let's close the paths just for neatness' sake. Not much of a neat freak myself, but you know. So this is a transparent color, but we might want to change it earlier, so I don't want to make it a giant pain in the butt. So canvas.width, so we fill the whole canvas with transparent. So then we keep this going. Oh yeah, and one more thing, to make it bounce off the walls. If this dot x is greater than is less than 0, or this dot x is greater than canvas dot width, so it's if the x is outside the canvas then this dot dx equals minus this dx, so it reverses. And then if this dot y, the same thing with the y is great. Then once again this dot y, dy equals minus this dot dy. So it's perfect. Now it bounces, so now let's initialize and put, like, I don't know, 50 particles. So we keep drawing it, and then update to animate it. And then we loop it by requesting the same animation frame. And then now let's call that function. Oh yeah, okay, so for some reason that's not working. Oh yeah, I see. So we want to stroke it so we can see the line. So now, as you can see, they're in proximity of each other, so they're connecting. Now there are a lot of ways we can do this. So let's make the proximity range a bit larger. Seems good to me. In this case, like in this case, if we make it canvas dot width, they'll pretty much all connect with each other. Yeah, as you can see, they're all connecting with each other. So let's lessen it. So it's working here. I think I like this one the most. No, definitely not. Let's make it 60, 70, 80. Yeah, I think I like 80 the most. As you can see, it creates a cool laser effect. So we could always make it connect to the mouse instead. So I'll say I'll create an object called mouse. Oopsies. So, and I'll give it a x that's null. No, not null dot math. That's not even a value. Just null. But then window dot on mouse move equals function event mouse dot x equals event dot x mouse dot y equals f dot y. Yay! So now we can take out this part because we're not connecting to particles anymore. Let's change this to mouse.x. Mouse.y. Yeah. And yeah. So as you can see, if it's in proximity, they connect. We did it. We made the proximity connection effect, also known as the Constellation Effect. Let me just beautify this code. Format document with prettier. Awesome. So now we have clean code and it's working. Let's go. Let's actually go. So make sure to leave a like and subscribe if you want more epic, crazy epic content like this. Check out my gaming channel too. And this is Dark Shadow Codes.